Hello everyone, good morning. So today we are going to finish lesson 7 day 3, and you will be finding complex solutions of the polynomial equation. Oh boy, just by the sound of that title, complex, we know that we are going to have complicated answers, right? Well, let's see. It is kind of long, but I think we can handle it with everything that we have learned so far. So let's go ahead and get started to take a look at what the problems are all about. So you are at this point solving for all kinds of answers with the rational zero theorem, and sometimes they're not very nice. So let's start with some actual nice answers that actually are real zeros and rational that you can just rewrite without having too much trouble. So number one, write the simplest polynomial function with the given roots. So we're given 3 roots clearly here. So with that, we can rewrite the polynomial function. Basically, they want you to be able to rewrite it as p of x equals the factored form. So what the factored form that gives you 1 is actually x minus 1. And the factored form that gives you 4 is x minus 4. And same thing, x plus 3 is going to give you a negative 3 as a 0. So now we're just going to go backwards. Basically, we're going to just instead of like getting the zeros, now we're going backwards and multiply so that we can get the polynomial function. So the first thing we're going to do is FOIL the first 2 parentheses. So we get x squared minus 4 minus 1. It's going to give us minus 5x and a plus 4. And then we bring down the existing x plus 3. And now we're going to superfoil. So we're going to multiply x cubed and then distributing that x through every term. So it's going to be minus 5x squared plus 4x, and then distributing the 3 through, so it's going to be a plus 3x squared minus 15x and plus 12. So bringing the balance, we're going to have p of x equals x cubed by itself minus 2x squared minus 11x and plus 12. And that is the polynomial function that produced the original zeros right here on this list. So that's the end of the problem. Hopefully that was not too bad. Next, we have 3 different zeros. So again, we're going to start by writing the polynomial using the factored form. So what gives me a 1/2 0 is 2x minus 1. And if you're not sure how we get there, you can set that equal to 0 and solve for x, and you'll realize that we're going to end up with x equals 1/2. And then x minus 5 and also x plus 2. So those are the 3 factors. And now we're just going to FOIL the first 2. So we have 2x squared minus 10. Let's see if we can just write it together. Minus 10 minus 1, that's minus 11x. And then finally a plus 5. And then bring down the existing x plus 2. And we're going to superfoil, guys. And so it's going to be 2x squared, distributing x minus 11x squared and plus 5x. Now we're going to distribute the 2, so that'll give us, let me change that to a 3. So 4x squared, and then minus 22x and plus 10. And now we're going to bring the balance, and so we have p of x equals 2x to the third minus 7x squared minus 17x plus 10. And that is the final polynomial function that gives us those 3 zeros in the beginning. And that's the end of that problem. So it is now your turn to try this problem, the same exact way that we just did it right now. So go ahead and pause and try the problem, and then tell me what you have and before you check your answer, okay? So hopefully you've had a chance to try the problem. So we're going to rewrite the polynomial using the 3 factored form for the 0, that is x minus 1, x minus 6, and x plus 1. So we're going to again FOIL the first 2 parentheses. So x squared minus 6 minus 1, that gives us minus 7x, and then a plus 6 at the end. We're going to superfoil with the last factor and then distribute the x. So we got x cubed minus 7x squared plus 6x, and then distribute the 1, that will be a plus x squared minus 7x and a plus 6 at the end. And bringing the balance down, we have p of x equals x to the third minus 6x squared minus 6x plus 6. And that is the final polynomial function that gave us the 3 zeros from the beginning. And so those are the simple ones that are straightforward, giving you the rational zeros. But now we're going to take a look at what are some other possible zeros that you're going to get. So you're going to be looking into irrational or complex roots. And they come in pairs. That's the important thing. They come in pairs. So keep that in mind. Where does the pair idea come from? Well, that comes from this formula that's right here, which is known as the quadratic formula. So remember, when you can't factor something, you use the quadratic formula, and it goes like this: negative b plus or minus the square root of b squared minus 4ac all over 2a. So some examples of, so that's why the plus and minus right there will give you the plus and minus, which is why they come in pairs. So it's plus and a minus. Okay, so let's talk about pairs. So square root of 5 and negative square root of 5 is a pair because of that sign right there. So it's a pair. Okay, so 1 plus radical 7 and 1 minus radical 7. Notice the middle sign is different. And then I and negative I, that's a pair. So these are all pairs. Notice, because the sign in the middle is different. So that is how we know that these complex roots. So any I you see, any I and any radical 7 or any radicals will be considered complex or irrational. Okay, so that is the reason why the irrational and complex roots come in pairs. So those are called the conjugates. The pairs, the twins, they are called the complex conjugates. Okay, so using there is a irrational root theorem that says if there is a square root and a negative square root, which is the conjugate, is also a root. So that's why they come in pairs. Same thing for the I. So if a plus bi is a root, then a minus bi, the conjugate, is also a root. So this is a lot of words, and I know that it's not that clear for some of you yet, but let's apply them in an example so you know exactly what we are talking about. So here's an example where they give you the roots of 5, negative 2, and then 3i. So like we said earlier, since the i's and complex roots come in pairs, we can just add a blank to the end and then fill in the blank with a negative 3i, because that is why they come in pairs. So now we are ready to write the polynomial function using the factored forms. So what are the factors that produce those zeros? Well, again, those are real. You already know that it's x minus 5 and x plus 2 from the previous examples that we did. And the same thing for the I. So it's just going to be treated like a factor. So it's x minus 3i times x plus 3i, because it's minus 3i, right? So it's plus. And now remember, you always need to work out the pairs, the conjugate pairs together. So they have to come in pairs. So we're going to FOIL these two, and you usually will be able to cancel the middle term. So see how there's a plus 3i and a x and a minus 3ix. So those will cancel each other out, as you can see, because this is a difference of square. And then at the end, we have a plus 9i squared. And in case you have not heard yet, we introduced to you the idea that I is equal to the square root of negative 1, right? So now I squared is actually equal to the square root of negative 1 squared, which means the square and the square root cancels out, and we get negative 1. I squared equals negative 1. So from now on, if you see I squared, you can go ahead and cross it out and replace it with negative 1. So now this whole thing right here just works out to be x squared minus 9. Actually, I made a minor error right here. The last term should be negative times negative is minus, is a negative times positive is a negative. So now negative times negative is a positive 9. So that is all we get from these two multiplied. And then we're going to bring down the rest of them. So we got rid of the i's now. We have 3 nice zeros, which are factors now. So we just need to work out and multiply those, and we're done. So we're going to FOIL this next. X squared plus 2 minus 5, which gives us a minus 3x, right? And then, oh, don't forget, we have minus 10 at the end. And then we're going to bring down the existing x squared plus 9 term from the imaginary from the complex roots, and then superfoil. So we got x to the fourth, then distribute minus 3x cubed minus 10x squared, and then I'm going to distribute the 9. So we get plus 9x squared minus 27x and minus 90. Finally, we're going to bring the balance. P of x is equal to x to the fourth minus 3x squared minus x squared minus 27x minus 90. And a word of advice for you is be very careful and slow when you're going through these steps until you're confident, because if you make a minor mistake in between on any of the multiplication, like earlier I almost made a mistake, then you're going to probably get your answer wrong. So be very careful with that. Okay? So now I'm going to do the next problem, which is over here. I'm going to bring it over here. So we have two zeros that are given. We're missing the conjugate, which is 1. I need to adjust the width here so it's not so big, the writing. So it's going to be 1 plus I, which is the missing factor. So now we are ready to write polynomial of x is equal to x minus 3 times x minus 1 minus I, and then times, I'm going to write it on the bottom, x minus 1 plus I. So it just looks a little messy right now, so I'm going to clean it up by distributing that negative there. So I'm going to rewrite this. Hopefully it looks better. And I'm going to have x minus 1 plus I times, right here, same thing, x minus 1 minus I. So that is what I get for distributing and getting rid of that ugly parentheses. So now I'm going to work out the right-hand side. Just focus on these two right here. Remember, the pairs need to be worked out together. So we have x times x, which is x squared. And then we have x times negative 1, that's a negative x. And then x times negative I, that's negative ix. Then the middle term, negative 1, is going to distribute to all three of them. So that's negative x. I'm going to line it up with the negative x here. And then negative negative is positive 1. That's different. So I'm just going to write it on the side. And then negative 1 times negative I, that gives me a plus I. Finally, I'm going to just multiply this, the I, with all three terms. So I've got plus ix, and then minus I, and then finally a minus I squared at the end. Okay, so luckily some of these terms will cancel out. So watch what happens when you have the negative ix and positive ix. They cancel out. The plus and minus I cancels out. And we previously said that I squared, whenever you see that, we're going to replace it with negative 1. So let's take a look at what we actually have when we combine everything. We actually have x squared minus 2x, and finally just 1, and then negative and negative is a positive 1. So 1 plus 1 gives me a plus 2. So that is what I get from multiplying these two big parentheses all together. So hopefully that makes sense. So you can go through it again if you need to. And then we're going to bring down the x minus 3. And finally, we're going to move on to get the rest of the polynomial function. So we're going to superfoil this. So we're going to have x times x squared, we get x cubed, minus 2x squared, and then plus 2x, and minus 3x squared, plus 6x, and minus 6. Bringing the balance down, writing P of x equals x cubed minus 5x squared plus 8x minus 6, and that should be the final polynomial function that produced these three ugly terms, zeros, in the beginning right here. And that is the end of the problem. Hopefully that makes sense to you. I know that was a big one, right? Okay, so let's go ahead and move on to the next problem, and hopefully you can try one now on your own. So let's go ahead and do this one. So it also has three existing terms, but if you notice that these two are actually complex, so we're going to need to bring in the list the rest of the factors. So if 2i is a factor, then negative 2i is also a factor. And if radical 3 is a factor, we have negative radical 3. So let's start writing the complete list of the factors. So it's x minus 2i, and I need to list the other 2i together, so it's x plus 2i. And then we got x minus radical 3, and x minus a minus, which is plus radical 3. And then finally, we have x minus 4 at the end. So those are the 5 lists. So there are 5 of them total, okay? Because the imaginary ones and the radicals, they come in pairs. So again, the reason why I lined them up next to each other is so that we can multiply them together. So now I'm just going to FOIL it, and because it's a difference of square, the middle terms we cancel out, right? So I have x squared, first term, and the last term, because the middle terms will cancel out. So it's a minus 4i squared. And we know that I squared is negative 1. So to simplify, this actually becomes x squared. Negative negative is positive 4. So this whole thing turns into x squared plus 4. Next, we're going to simplify the same thing here. So we got x squared. And then the middle terms will cancel out. And at the end, we have radical 3 times radical 3. So it's going to be a negative. Radical 3 times radical 3 equals 3, guys, because it's a radical of 9, which equals 3. Okay, so hopefully you guys can understand that. So I'm just going to write the final answer, which is 3 at the end. So this whole thing becomes x squared minus 3. And then bring down the x minus 4 as the last term. And let's go ahead and FOIL, then continue moving on and multiply to get the rest of the polynomial. So x to the 4th minus 3x squared plus 4x squared minus 12. We can simplify definitely the middle terms. So we'll have x to the 4th plus x squared minus 12. Then finally, going to multiply it with the existing x minus 4. We're going to superfoil. So superfoiling, we will have x to the 5th, distributing it through everything, plus x cubed minus 12x. And then distributing the 4 will be a minus 4x to the 4th minus 4x squared, and then plus 48. So I'm just going to line this up. It doesn't look like there's any like terms, so I'm just going to combine everything and put it in standard form. So x to the 5th minus 4x to the 4th plus x to the 3rd minus 4x squared minus 12x and a plus 48. Wow, that was one long problem, right, guys? But aren't we so proud we did that? Okay, so that is the final polynomial function that produced the 5 zeros. So the reason why it's so long is because it has a total of 5 zeros here. Okay, so that's that problem, and let's go ahead and have you guys try these two. I know they're kind of long, but go ahead and try at least one. You can pause the video and try it. Hopefully you've had a chance to try the problem. So let's go ahead and make a list of the rest of the zeros. So there's radical 2 is an answer. So I would think that negative radical 2 is also an answer. So let's write down negative radical 2. And then if negative 3i is an answer, then 3i is also an answer. So those are the two that are missing. So let's go ahead and make a list of the polynomial factors. So x minus radical 2, again, they need to come in pairs. So let's write down the x plus radical 2 as well. And then we got, let's put the I first, the imaginary. So it's x plus 3i, and then x minus 3i. And don't forget we have the 0 by itself. So it's x plus 5 that produces a negative 5, 0. Okay, so we have our 5 factors. And again, we're going to work out the complex ones in pairs. So again, this one is going to give me x squared minus 2. And this one is going to give me x squared plus 9. Okay, so you can work it out again to make sure that those are the correct factors. And then next we're going to FOIL this. So we got x to the 4th minus 9, actually plus 9 minus 2, which is plus 7i squared, x squared, and then minus 18 at the end. Then we got the x plus 5 that we're going to bring down, and finally we're going to superfoil. So we got x to the 5th plus 7x to the 3rd minus 18x, and then distributing the 5, we have a plus, let's put that underneath, plus 5x to the 4th plus 35x squared, and a minus 90. So again, we're just going to line up everything in standard form. So p of x is equal to x to the 5th plus 5x to the 4th plus 7x to the 3rd plus 35x squared minus 18x minus 90. And that is the final answer for the polynomial that produced those 5 zeros on top. Okay? All right, so let's go ahead and move on to this one on the right hand side. And so again, if 2 plus 3i is a 0, then guess what else? 2 minus 3i is also a 0. So we have a total of 3 zeros. So let's go ahead and write the polynomial function. It is x minus 2 plus 3i, and then x minus 2 minus 3i, and then finally x minus 7. So again, we're going to rewrite these right here without the parentheses. So we got x minus 2 minus 3i times x minus 2 plus 3i. Now the little parentheses are gone, and we're going to superfoil right here. We got x squared minus 2x plus 3ix, and then distributing the 2, negative 2. So that gives us negative 2x plus 4 and minus 6i. And then finally, taking the last term and distributing that through every term, that's going to give me a minus 3ix, and then a plus 6i, and finally minus 9i squared. So let's go ahead and cancel the opposite terms here. And so that gives us a total of x squared minus 4x. Don't forget I squared is negative 1. So we got a plus 9 at the end right here. So 9 plus 4 is 13. And then bring down the x plus x minus 7 term here. Finally, we are going to just superfoil. So x to the 3rd, distributing it to the next term, minus 4x squared, and then plus 13x, and distributing the minus 7, we got negative 7x squared, plus 28x, and then a minus 91. Final answer for the polynomial is going to be x to the 3rd minus 11x squared plus let's see, should be 41x minus 91. And so that is the, actually, you know what? I'm just double checking my work here. So we got x to the 3rd minus 4x squared plus 13x, and then minus 7x squared plus 28x minus 91. Okay, so that looks right. So the polynomial function is right here given, and that is what produced those 3 zeros on top right here, and that is the end of the problem. So looks like we're done with all the problems. There is a discussion question. Says number 1, if 1 zero of a 4th degree polynomial function is rational, what must be true about the other one? So it's saying that if you have x equals 1, 2, 3, and 4 zeros, one of them is irrational. What is true about the other 3? Well, you've got options. You can have each one of them rational, or you can have 2 of them rational, and then 2 of them like a radical, negative, right? Or an I and a negative I. But since they come in pairs, so you must have like either one pair or all of them as rational. So that would be the answer for that one. So the last question, is it possible for a 5th degree polynomial equation to have one real zero? So is it possible to have one to have no real zero, sorry, no real zero. Well, actually the answer is no, it is not possible. Because if you actually look at the imaginaries, the radicals, and the imaginary, the I, they come in pairs, right? So it's either, if you have 5 spots, it's either they're going to be all reals, all rationals, all reals, or you can have pairs. So you can have, let's say, a radical and a negative radical, I and a negative I, but one of them will be left over, and that has to be a rational. So it's not possible. In fact, you can also have one pair that is like either a rational, which means complex, and 3 rationals, or you can have all of them actually rationals. Okay, so the underlines represent the rational. So those are the different combination. So you can have 1, 3, or 5, but you cannot have 0. Okay, so that is the end of the problem and also the end of the lesson for 7.2 day 3. And you can go ahead and proceed to your assignments. Have a wonderful day. I will see you next time.